My answer is a twofold answer. I think it depends. In semiconductors, it's not a clear answer. In case of metals, it's a very clear answer. I think everybody of us know copper. It's a very important metal for electrical applications. And it makes a lot of sense to recycle copper. This we're doing since many years, and we have to continue it. That's a clear answer. In the case of the semiconductors, and those are the materials that have the active part in the electronic devices to switch currents, to have a microprocessor running, sensors, to emit light. There it depends on the kind of material. Let's say the following, for example, gallium nitride, indium phosphide. So materials with gallium or indium inside, there it would be very important to have such a circular economy process because those materials are rare. Also, we're not producing them directly. It's more like an indirect process. For example, when we are producing aluminum or zinc, there gallium and indium are side products. And for those metals, recycling and circular economy would be very important, especially for us in Europe. Silicon is a material that we have a lot plenty on our Earth. And in electronics, the major point is to have high purity. So really high purity. And that's the main obstacle also at the same time. So if we're talking about recycling of silicon, it makes sense, for example, to reduce the amount of waste. Like if we are having old solar cell panels and so on, we want to reduce the amount of waste. For this, it makes sense. But the other thing is it should be high purity material. And in Europe, there are a number of companies that are producing high purity silicon. So that's not really a bottleneck. The material, the atom silicon is available. So there's no limitation on Earth. And in addition, we are producing silicon in Europe. In the European Union, for example, Germany is strong in this, also other countries. And in Europe, also Norway, which is related to the European Union. It's not a member, but it's a European state. And we have contracts. So they are producing a lot of high purity silicon. So I think for the silicon, we have the high purity material, especially for the microelectronics. If you're coming for solar grades or for solar cells, such silicon, there the recycling could make to a certain amount sense because we don't need to achieve this high purity. But nevertheless, also in this case, I think the mass production of silicon, we are quite strong in Europe. I think another point is we are having the material, but we are not big enough, strong enough in producing the electronic devices and the systems. If I look at the big companies, let's say there's Infineon very strong, ST Microelectronics is very strong, ABB, Bosch, and other companies. I named just a few. But compared to the world market, it's just a small number. So we are not strong in producing the devices. That's our main problem. And we're having the raw material in this case, also in the case of high purity, but we are not very strong in the production. That's our main thing. And so circular economy, recycling, it makes sense to reduce the amount of waste. But for silicon, it's an abundant material, so we have enough. Like I was answering in the last question when we were talking about silicon, in silicon, I think we have a large amount of silicon available for our production. So I don't see there are problems for scalability issues. But looking at other materials, there we have them. I mentioned already in my first answer when we discussed which raw materials are rare, like I mentioned indium and gallium for the semiconductors. And their scalability for the future, of course, it's an issue. So I think we need clear plans. What should be our production in 5 and 10 years from now, so that we can look now for the solutions to have enough raw material. So we must set up our fabs in advance, and this needs investment, because first you just pay, you don't receive anything. And this is also where Europe, the European Council could help, could push such technologies that we know they are important in a few years in semiconductors, or think of all the materials that we're using in battery technology, which is also related to electronics, or all kind of other devices. So I think in such case, we need to identify the material we really want to use them in the production in Europe, and then we have to look for this upscaling of the production or the recycling. And I see the biggest bottleneck for materials in semiconductors, and then related to electronics, but very interdisciplinary. If you think of battery technology, for example, it's exactly the same. Photovoltaics, maybe the problem is not that big. We rely a lot on silicon there, and silicon, we don't have a problem. There I can give you short and precise question. It's all about purity. So in semiconductor materials in particular, the purity plays the most important role. Usually the semiconductors in the electronic devices, they make use of so-called dopant atoms. So these are other atoms in the crystal implemented intentionally, and they fine-tune the electronic properties. They fine-tune the functionality of the device. So if you have contamination, if you don't have a pure material, your doping doesn't work, your device doesn't work. And this holds for all kinds of electronic devices based on inorganic semiconductors or organic semiconductors. It's always the same. But also in metals, if they are not really pure, you also have a lower performance. Also there, purity is the main thing. But semiconductors, I can just say purity, purity, purity. And that's also the problem with recycling. Usually after devices have been fabricated, those materials, there are other metals, there are other layers added to the semiconductor. And it's very difficult to get rid of them during recycling. So the purity issue also makes the recycling expensive. So, but the answer is purity, purity, purity.